Now that we've taken a look at some of the general information about our actual connectors, let's take a little bit more closer look at the actual devices themselves. The first device we're going to look at is going to be our PATA device, Parallel Advanced Technology Attachment. And as of recently, it's been more replaced by our actual SATA connectors, but they are still around, so it's good to understand them and understand how they work. We actually configure PATA devices with where we locate them on the cable, as well as jumpers that are actually on the PATA devices. And in the BIOS itself, we can actually select information on which PATA device we want to be first and which one we want to be second. We call this the primary and the secondary drive. PATA cables are 40-pin cables with two different types of ribbon attachment. You'll see 40-pin cables which have 40 cables on the ribbon attachment, and you'll also see 40-pin cables that have 80 wire attachments. The wire that we want to use now are going to be the 80 wire attachments. This assists us because each of the data cables actually has an additional cable paired with it, so it's better for data transfer, and it's just better for allowing us to have multiple devices. Our particular PATA cable that we have here, again, PATA also known as IDE cables, we see is color coded. Now we have a blue end, a black end, and a gray end. Our blue connector is what we plug into our motherboard. Our gray connector is our secondary drive, and our black connector is going to be our primary drive. We have two PATA drives here that we can connect into. And then we'll notice how we can have these multiple drives in our computer with just one connector connecting to our motherboard. Now, if you do have a cable that isn't color-coded like this one is, just remember that the cable has a long segment and a short segment between two connectors. The longer segment between two connectors, at the end of that longer segment, is going to be where you plug into the motherboard. On the shorter segment is going to be your two drive connectors. The two connectors that we have on our actual SATA cable allow us to designate, again, our primary or our secondary drive. Now, our primary or our secondary drive helps our BIOS when it boots to determine which drive it needs to connect to when it's going to boot the operating system. Now, we can set settings by placing the drives on the cables by changing our BIOS, or we can actually also set jumpers on our drives themselves. The jumpers, again, are small pin configurations that are on the back near where we'll plug in our data cable for our IDE. Our jumpers will look similar to this block here, and then we'll have our data connections over here for our IDE cable, and we'll have our Molex power over here, and in the middle we'll have our jumpers. These jumpers are just small metal pins that are held together by a jumper block, and where that jumper block is lets us designate exactly what our selection is based on those jumpers. Now, on most of our drives, we'll actually have a small diagram that will show us where we want our jumpers to be. On this particular drive, our second cable selector here, if we have this block jumped here, is going to be cable select mode, usually abbreviated CS. Cable select mode, it basically says wherever this drive is on our cable, and that's what it's going to be, master or the secondary. And this is where we actually usually want our jumper to be if we don't want to mess around too much with determining the exact place the jumper wants to be. We want to only worry about having the drive on that correct location on the cable, and we'll let the cable select do its job with knowing that it's on the cable in either the primary or the secondary position. Our next type of connector that we have for our internal is going to be our SATA connectors. Now, we're going to dive a bit more into our SATA connectors, and SATA, of course, stands for our Serial ATA, or Serial Advanced Technology Attachment. Now, we're wondering how our Serial ATA connectors compare really to our parallel ATA connectors. When we think serial and when we think parallel, we're not talking about the type of cereal you have for breakfast. We mean that this cable is going to send information from our device to our computer one bit at a time, or one at a time. And this is going to be our serial. Parallel which is our older connector. We'll have our device, and these actually transfer in parallel, whereas these may be traveling one way and these may be traveling the other way. At first glance, we think, well, how is serial faster than our parallel connector? Their serial cable is a bit bigger, it has more wires in it, and you're telling me that it can do two ways at the same time. Our parallel actually contaminates our fields when we're sending information back and forth. That information traveling in parallel, that data and the electricity traveling in parallel, can cause crosstalk across the wires. The electricity can start interfering with the other wires. This can lead to issues and has to be closely monitored. Whereas our serial connection, because we're only going one way at a time, we're not going to contaminate that as much. We're not going to have as much crosstalk. This, in combination with advances in how the information talks across the cables, even though the SATA connector has less cables, the SATA only actually has 7 pins, whereas our PATA connector or IDE connector has 40 pins. Our SATA connector is still able to transfer data a lot faster than our PATA connectors and stay smaller than our bulky SATA connectors where we have our large 80 wires. Our PATA connections are only going to be one-to-one. So we're not going to have any additional connectors on here like we do with IDE. With our PATA connectors, we have one drive and we have one motherboard attachment. So it's a one-to-one connection. Our SATA power is a similar looking cable to our SATA connector, but it's a bit wider. It's a 15-pin connector that we plug into our drive. So we now have our two connectors, our data and our power. On the other side of this adapter, we see our Molex power, which is a 4-pin power. This Molex is the type of power cable that actually powered our IDE connectors. But when we switched over to our SATA connectors, we can see that they're a bit smaller, a bit more streamlined, but they also have 15 pins on them. In addition to our standard SATA connections, we also have eSATA, which is our external SATA. Now our external SATA allows us to plug in, say, an external hard drive using a similar SATA type cable, but the ends of the cable are actually different. Inside of our computer, when we install a SATA, say in a SATA adapter card, we actually have what's called an eSATA header, which changes that SATA to an eSATA interface that our computer can use.